The broadcast is now starting. All attendees are in listen-only mode.
Morning, everybody. Welcome to the Designing with QtPro sound masking webinar. As we'll see, we'll start in about 20 seconds. So just give everybody time to join. Still people joining. Going into my dashboard. Okay, so good morning, everybody. Well, good morning UK time. Good day to whatever time it is, where everybody is, and welcome to everybody. Thank you for joining. Just to introduce myself to you, my name is John Caton. I work for Biamp Systems as a technology architect. I'm based out of near Manchester in the UK, and I work with the European and African team. Prior to that, I worked at Cambridge before the takeover, and as you can see, prior to that, consultancy, and also I have my own installation company. So here at Biamp, what do we do? We connect people through extraordinary audio-visual experiences. And for those of you who do not know Biamp, we have products that range all the way from the beginning of the audio spectrum right through to the end, from microphones to loudspeakers, including control, DSP, and so on. The products that we're relating to today are the sound masking brand that Biamp have, and in this brand they fall under the Cambridge product range, and today we are solely concerned with the QtPro part of that range. We also have a second range, Dynasound Pro, which would be covered under another webinar, but with the two product ranges we have sound masking solutions that are suitable for any type of facility, application and consultant specification. So what I want to go through today with you is to recap on the 4 key elements for an effective sound masking system. We covered these in a previous webinar, but I just need to recap these, and also for maybe people who haven't seen that one. Just do a quick recap on the QT products that we're talking about for the designs. We will go through some proper layouts using the Biamp guidelines, and we will talk about the wiring configurations that go with these designs, the differences between active emitters and standard emitters, and some examples. And we will also have questions too, if needed. So I'm not too sure you're getting my screen, so just bear with me 1 minute, please. My apologies for that. I think I was showing the wrong screen. Are we showing the right screen correct now? If somebody could let me know, I would be grateful. Okay, many thanks everybody. My sincere apologies for that. Technical issues with the software again. So I'm hoping that I'm correct now. Is everybody seeing the 4 key elements? Yes, they are. Thank you very much. That's perfect. Okay, I will start again. My apologies. So the 4 key elements for a successful sound masking system are the following. We need to make sure that we have the uniformity, the zoning, the spectrum, and the level correct. The key one that we want to be concerned with today is the uniformity and the zoning. The uniformity and the zoning are the main parts that we have in the design part of the equation. The spectrum and the level fall under how we commission the sound system. So the two that we're concerned with today are uniformity and zoning. A recap on the QtPro direct field sound masking, which is what we're talking about this morning. So this is where speakers or emitters are fitted in the ceiling itself. So the ceilings go in the ceiling, and the sound comes down from the ceiling to the users. And the reason why this is an ideal way to do sound masking is quite simply because the only part between the listener and the emitter or the speaker is air. So this way that we get consistent results without other factors causing some way of interrupting the sound. So with the QtPro system, there are 3 core components. You have the processor, you have cables, and these cables form 2 types of cable. You have what we call the home run cable. The home run cable runs from the control processor to the first emitter, and then from the first emitter we then have what we call interconnect cables, and the interconnect cables, as you would expect, interconnect the speakers. Now all these cables that we use in our systems are category 3 or above cables. So they're just standard Cat cables. We normally use Cat 5 in Europe. We can use anything from Cat 3, like I say. The reason why Cat 5 is used more is it's quite flexible, and if we get up to Cat 6 or 7, they can be a bit stiff, really. We do not need to have screen cable, just a normal cable, but we do need all 8 conductors on the cable. Our control processors, we have 3 control processors, QT100, 300 and 600. The differences between the 3 are the 100 has 1 zone, 300 3 and 600 6. All these emitters have 2 runs per zone, and the difference between the 100, the 300 and 600 is mainly that the 100 cannot have any scheduling or equalization. However, for the purpose of design, all 3 are the same. Another footnote with the 100 is you cannot use the active emitter with the QT100. We have 2 types of emitters or speakers. We call them emitters. We have the standard emitter, which is the one shown on the screen. Standard emitter works from 200 Hz to 5 kHz. it will reproduce up to 60 dBA of sound masking, and it has attenuation in the 3, 6, and -3, -6, -9 if required. This emitter will work with any of the 3 controllers. We also have the active emitter, and the reason for the active emitter is that it has a wider frequency range. So the active emitter will work from 125 Hz for sound masking and 105 Hz for paging and music. Slightly different attenuation. We have -1.5 dB steps on the attenuator, and it requires a power supply and an injector, which I'll explain later on. And it is slightly louder. It's about 10 dB louder than the standard emitter. So with this emitter, we can play paging and background music as well as sound masking, although it is useful for sound masking only applications as well. The emitters are all the same width, approximately 90 millimeters, and they are standard fit into a standard ceiling tile. If there is no ceiling tile to use, we have this range of brackets. The most common one is a universal bracket where that can go straight on the ceiling structure and point down. We also have the pendant mount for suspending in free air, and the drywall mount. The adjustable plenum back can and the drywall kit we don't tend to see a lot of in our region, however they are available. So moving on to designs. There are several key things that we need for producing a design, which we should try to get before we start. We need to know the ceiling height, which is crucial. We also need to know what type of ceiling it is in the building, mainly for the type of brackets that are used. However, that's not too necessary for the design, but it is moving forward. Do we want background music or paging, so we know which type of emitter to use? And we need to know what the type of spaces are, which I will show you in a short while why. And we also need to know if there are anything that we need to be aware of in the design so that we can make allowance for that. And crucially, we must have either a CAD drawing or a PDF drawing, and the PDF must have a reference item to scale off. We can use doors if we wish, but ideally, if we have something to scale off, then we can get an accurate design. For designs, I have 3 golden rules. We should not start a design without enough information to complete it. This might sound straightforward, but there are quite a lot of times where you might not get all the information and we end up doing a design that might not be suitable. Secondly, trust your audio system knowledge. So the emitter is effectively a loudspeaker. So if you were designing a loudspeaker system or an audio system, trust your knowledge. And thirdly, if in doubt, ask. We have huge technical resource here to help you at Biamp. Not only myself, I have colleagues all over, and all the regions we have people who you can ask. So please do ask if you have any doubts. We also have a design guide, which is published on the website, and this has a comprehensive design guide of how to design our systems. So this is on the website, and we can send the link if anybody requires that as well. The only thing I would say about the design guide, it is in imperial measurements, not metric too much, although there are some metric. However, the design guide is there. So how do we go on designing a QtPro sound masking system? The first thing we need to consider when we're doing this is identify the areas of coverage. So in doing so, we need to consider within the area which areas are acoustically similar rooms. So if we have an acoustically similar room, we are talking about maybe in this application of a typical office area, we will have an open office area. And in the open office area, they will be looking for reduced distractions. We will also possibly have some private offices, which are all of a similar size, and acoustic property. So we look at those. We also look at a corridor or transition area where there will be a way through. So we'll be looking potentially for privacy from the conference room and the private offices also. And occasionally we might look to cover the conference room as well. The reason being is that the conference room might be distracted by people walking and talking in the corridor. So when we consider these areas, because these areas become the zones which we form in our system. So the reason why we want to separate areas into zones is because, as well as being acoustically different, when we come to tune the sound masking system, they will also need a different level in these areas, because in the open office area, there is slightly more sound. In the private offices area, they're a private area, therefore they're generally a little bit quieter, so they have different requirements. So this is why it is important that we consider these areas so that we get the zones correct and we can design accordingly. The indications that I've shown you there for the dBA levels are general European examples. They could be higher in some countries, they can be lower in others, and there are different requirements. The key point is, going back to our 4 key elements, we need to be able to adjust the level and the spectrum per zone to make sure that we have an effective system. So, where do we start? The emitter or loudspeaker placements are a function of the room space, so we need to get that correct. A very key point is that sound maskings are less forgiving than different types of audio systems, mainly because of the frequency variation. So we do need to pay attention to detail on them. And quite often, if we have a system that's performing badly, it will normally have one of the 4 key elements wrong. So it's key that we try to get the uniformity right. One key thing that I want to explain about our CSM emitters is that they have a very small driver, 1.25 inches roughly. So this allows us to have 170 degree nominal dispersion, which is considerably wider than normal ceiling speakers that you might be used to. The way that we do our layout is we put the emitters into grids across the space. So we do this depending on the ceiling height, generally. So as I'm showing here, the table at the top is a very broad spectrum of where we aim for. So if we have a ceiling that is up to 2.7 meters, then we use a 2.4 meter grid. Anything lower than 2.4 meters, we still have the 2.4 grid. And on the other end of the spectrum, anything higher than 3.6 meters, we still always retain a 3.6 meter grid. Areas that are particularly high, we recommend that you give us a call to establish whether sound masking systems will be effective. The active emitter will work up to about 5.5 to 6 meters. However, there are some factors that we need to consider. The Same layout principle is used for active and standard emitters, so it's exactly the same principle. The only difference is the wiring. So to have a full look at the ways that we lay it out, this is shown on this chart. I will reiterate, these are all in the design guide, so that everything is there, which we do. The key thing here is the far right hand column, where we say that anything up to 60 centimeters tolerance there is. So we can move anything within a ceiling tile difference without showing an effect. You might also notice that our calculations of meters to feet are not literal meters to feet. We take the ceiling tile as the height. So that's why you will see that everything relates to a ceiling tile in the 2.4 and 3 meters and so on. I have a question here from somebody saying, is there any layout software like Ease Address? The emitters are not covered in Ease Address, unfortunately. So we don't actually have any software, but I will show you how further on how it is quite straightforward to do designs. There is currently no software as such, although we do have the GLL files if somebody wanted to do it in proper ease. So we have the emitter spacing that we work on, and what we would do ideally is aim for a grid alignment of equal spacing. Therefore, we get the uniformity. So we want to try and retain the grid as much as is possible. The spacing is determined by the coverage pattern of the emitter and the ceiling height. So the ceiling height, as we've shown on the previous charts, is important. And with our sound masking systems in the direct field, we are aiming for plus or minus 1 dB uniform sound coverage. And that's the goal that we're aiming for. Some of that is assisted with the tuning, but the key to it is getting the design right. So if we have a ceiling height that's 2.4 to 2.7 meters, referring back to our previous chart, we were aiming for a 2.4 meter grid spacing. So in order to achieve that, we would go for a minimum of 0.6 of a meter from the wall or other boundary, or 60 centimeters or 600 mil, however we wish to look at it, and a maximum from the boundary of 1.2 meters, or half of the distance of the grid is that we're aiming for away from as a maximum. And as I said previously, we can move an emitter by 60 centimeters in any direction to avoid any form of conflict. The golden rule is that closer together is better than further apart. So if we have to move anywhere, we can go closer. And as I said previously, also trust your audio knowledge, because you will be able to know how the system should perform. If we go to the next height, from 2.7 to 3 meters, then we have a 3 meter grid spacing. And again, this is very, very similar to how we were before. So we have minimum of 60 centimeters from the wall or the boundary. The difference here is that we now have the half spacing, so we have 1.5 meters maximum from the wall. And again, as we said previously, we could move any emitter 60 centimeters in any direction without affecting the performance of the system. The same for the highest category. So this is where we have a 3.6 meter grid spacing, and the same principles apply again. We have a minimum of 0.6 of a meter from the wall or another boundary. We have a maximum of a half spacing from the wall, so that is 1.8 meters maximum. And again, we can remove any emitter 60 centimeters in any direction without conflict. So just to reiterate, that is the furthest spacing that the QtPro system can be. So if the ceiling height goes any higher, we always retain that spacing. We cannot go more than 3.6 meter grid spacing. Some good tips if we get an area where we cannot get the ideal grid in. So we're always better to overlap rather than gap coverage. So in this instance, I'm showing where it should exactly be 3 meter spacing. So in this case, we're going to 2.4 above. The minimum spacing should be at least 1.8 meters to avoid hotspots. So we should never have emitters that are closer than 1.8 meters together. And the reason why we say the 60 centimeters minimum from the wall is because if we get too close to the wall, then we can start getting the boundary effect or room gain, which is the same phenomenon. So that will affect the uniformity. If for any reason we have to go closer to the wall for architectural or structural reasons, then we recommend that you use the tapping on the emitter to reduce the level. That would form under your commissioning part in it. So when we resolve, if we have problems when we're laying emitters out, we try to move the fewest number of emitters if we can to try and keep the grid pattern intact. And also, if I was moving any out, I would move them in the middle of the room to get them closer rather than the edge of the room, as a rule. So those are the rules for the open areas or the larger spaces. When we look at the private areas or internal offices, then we would look at different rules to a degree, and these basically are we should always have a minimum of 2 emitters in a room. The reason for this is that we don't want somebody to localize on the sound. It wants to become part of the room where it's not a localized sound. We always try to avoid 60 centimeters away from the walls and boundaries where possible. And we have a minimum spacing of 1.8 meters. Now, in some rooms, this is quite clearly not possible. So we have to, these are ideal targets. But if the room is a small room, we still should have two emitters. Therefore, it might be closer than 1.8 meters. And when we come to commissioning, then we might need to adjust the tappings on the emitters. If we have a room that's only used for less than or for a short period of time, we can go down to 1 emitter. And this is shown on this table here. So this is a typical layout that we would like to do in rooms based on the square meterage. And what we say is if the room is only used for a short period of time, then we can put a single emitter in, and we really talk about the maximum of 30 minutes being a short period of time. As I said before, these charts are in the design guide, and you will also get a copy of the presentation on PowerPoint with these in. So conference rooms are the same, generally the same rules as a closed space if they're small enough, or if they're a larger conference room, then you might go up to the standard rules. What I would be wary of with a conference room is you do not want the sound masking too loud in a large conference room, because it will defeat the object of the conference room. However, a conference room with sound masking at a lower level will make the meeting room slightly more private. We also consider we have a volume control unit or a room control unit that we do consider using to mute the sound masking if required. In the corridor areas, we treat a corridor as an area which is an enclosed area. If the area adjoins an open office, then we would try to treat the corridor area as per the open office. Again, they follow the same rules. We try to have 60 centimeters away from the boundary wall if possible, and we keep to the 1.8 minimum spacing. Other than that, the spacing is the same theory as the ceiling height in the 2.43 meters and 3.6 meters. So just to summarize what we've talked about there, we need to aim for a very even distributed emitter layout if possible to give the best uniformity and the best experience. Very important that we separate the zones correctly. We should use the room boundaries to determine where the beginning ends. We do not ideally want somebody walking into an area with no sound masking. It should, in the middle of the room, the whole room should ideally be covered if it's possible. There's a couple of tips that I have, is always try to use your controller zones up. So if you have a 6-zone controller and you've only used 4, then maybe look at splitting the main area into 2 zones, for example, so that when you come to commission the system, you've got a smaller zone that you can commission separately and get the spectrum a little bit more correct. And I would also try to avoid large zones. The controller will allow you to have 60 emitters per run per zone. So in theory, you could have 120 emitters on one zone, which would be a very, very large area to try to commission. So my recommendation is always to try to keep to about 66 or 2/3 of the zone. So if it's a 60 standard emitter system, I would try to limit it to 40 emitters where possible. As I said, these are ideal scenarios, and it doesn't always work that way, but it's a good rule of thumb. So we've laid out the emitters, and the next portion that we need to consider is how do we wire these emitters together. Now, with our sound masking systems, something that's very important to note is that we use, in each zone, we have 4 sound masking spectrums all working together. And there's a very good reason for this. It is so that we avoid something that's called comb filtering, where you have speakers on the same cable run. So our sources are non-coherent, which is a different signal. The reason why we want this is that if all the sound masking systems were on the same, all the signals were on the same amplifier channel, then in between each speaker, we would get something like this going on. So where we have coherent signals or the same signal, then we get this type of arrangement, which is not ideal when we want a constant uniform sound for sound masking. So in order to avoid this, the way that the systems work is that we have 4 audio channels. They're all non-coherent. So we have channel A, channel B, channel C, channel D, all coming out of the same controller, whether it's the 100, the 300, or the 600. And the emitters do not need any selection to choose the channel. It's all done automatically. So every emitter is identical. It just depends on how we wire the systems together. So this is why it's important to note that we have four channels coming out of the controller. Just at this point, I'll just take a couple of questions that are here, but which are relevant. How do we address deployment that requires more than 6 zones? To do that, we would quite simply just have another 6-zone controller or a 3-zone controller. And there is a second question. Is there a same for the partition that goes all the way up to the soffit? We treat, that's from Robert, we treat the ceiling height as a ceiling height. So whatever's going above the ceiling does not matter in the direct field. We're only concerned with the area below the ceiling. When we have 2 emitters in the room rather than the 4 emitters, that's another question that's come through in the enclosed space. The reason why we have the 2 emitters in the room is because if we have 4, there is no need for the 4 channels, because we have 2 non-coherent channels anyhow, and there will be too much sound in the room. So once we have these, that's the reason why we have the 4 channels. We then need to determine the wiring, how we're going to wire it. So the first key thing that we need to find out here is where the control processor is going. The control processor can QT 300 and 600 do come with a optional rack mount brackets if we wish, or they can be wall mounted. Normally they would go in the control room or an IDR or somewhere. So from the control processor, we need to go to the first emitter. We would always try to minimize the cable distance to the first emitter, ideally. And then we go from that emitter to the next one and so on. And we normally follow something like this type of arrangement. So you could go vertically up and down or horizontally. From there, that would be zone 1 that we talked about. This is the same example we've been showing through. Zone 2, which is the private offices, again, you follow the same procedure as shown here. And similar with the corridors and the conference room. We need to make sure that we've not exceeded the maximum number of emitters, that being for the standard emitter 60 per run, and for the active emitter it is 25 times 2 from the injector. So where we talked about the 4 channels, we need to make sure that the adjacent emitters are not on an identical channel. This only affects you can only have a conflict on the same zone. So the run that we've done here, as you can see, we come out of the control processor, we have channel A, followed by B, C, D, and then so on. So we have no conflicts here. Now the conflicts are only in a straight way. Diagonally, there is nothing we can do about diagonal conflicts, and they do not cause a problem. It is only when they are in a straight line, the horizontal or vertical line. And like we said, they can only happen on the same zone. If we had to have a larger space where we wanted to run 2 circuits in one zone, this is perfectly acceptable. The key point is that out of channel A, excuse me, out of run A, we start at A, and out of run 2, we start at C. So there would not be a conflict that way. And because we start with the A's and the C's, we will avoid cone filtering. Excuse me. Where we will get conflicts is if we have a different cabling path, and so we're trying to keep to the same arrangement, we will have problems. As an example here, this is where we have the conflict of showing we've got 2 C's and 2 B's together here. With regards to different types of emitters, you cannot mix the active emitter and the standard emitter on the same zone, but you can have standard emitters on one zone and active emitters on another zone. To summarize on some key points here. Each area requiring a different level gets a separate zone. This is what we talked about. Don't exceed the maximum number of emitters per run. This will cause the system not to work correctly. And a key point that I mentioned before is always try to use all the zones up. So that if we use the zones up, we have far better chance of an effective system. Cable distances or maximum cable distances. With the standard emitters, we have a total distance of 300 meters or 1,000 feet or 330 meters to be exact, and that is per run. So out of each run, you can have the same. So in total, you can have, like I said, 120 emitters of 300 meters each way. For the active emitter, it is slightly different. On the active emitters, we have out of the controller, we go into an injector, and from that injector, we can have up to 2 lots of 25 active emitters per run. Again, the distance is the same. It's 5 meters per emitter, so it's 125 meters maximum from the injector to the emitter. So the injector can go in the field. It does not have to stay in the control room. It just needs a power cable to link the power. We show a maximum of 125 meters. However, you could also put a larger cable in and it would be fine. But generally, you would not need to do that. You work the wiring around differently. So in total is 330 meters maximum from the controller to the end of the last emitter. And again, you have the same out of zone, out of run 2 if you wish, or another zone, you can use that. And the 2 items that we use to connect the active emitters are the power injector and the power supply. The power supply can do up to 150 emitters, as long as you do not have more than 50 per channel. You can use each channel for more than 1 power injector. When we do our designs, personally, I use AutoCAD where possible. We have some blocks that we have designed, and they go on as probably quite difficult to see there, like so. So the typical layout following the guidelines that we've discussed on here. And then following the next stage, if we add the wiring diagram would look something like this. You can also use PDF. If we do it on PDF, personally, I use Bluebeam, although any PDF writer can be used. And following a similar format, get a scale off the drawing somehow. In this case, we had to use the door. And we could lay out the emitters like so. Now, what you might notice on here is that the emitters are not following an exact grid. This is because of the size of the space where we had to put 2 in the middle to keep the uniformity. So that's the PDF. I have some questions that have come through, which I will go through. So we talked about why we need more than 6 zones. That we duplicate the controllers. Very key, an interesting one here. Can we install the emitters closer to 60 centimeters to the wall if the corridor is less than 1.2 meters? Yes, the answer to that is we will have to. So the rules that we've gone through are in the ideal world. In applications like that, where architecture there is nothing we can do, then we have to accommodate those accordingly. QT300 has 4 generating incoherent signal that you mentioned. So yeah, so in relation to this question, the question is asking whether if we have 4 incoherent channels, several emitters will be on the same channel. The emitters are on the same channel, but as long as they do not go next to each other, like we showed in the snake type wiring arrangement, then we can avoid the conflict. The QT100 takes in. No, it's not 6 emitters. This is from can I get wall mount case? Oh, yeah. So this is a key one. Somebody's asked whether we can put emitters on the wall or is it only ceiling mounted. So if we go back to the 4 key elements where we want uniformity, when we mount emitters on the walls, it is very, very difficult, if not impossible, to get uniformity. So we should always put the emitters hanging down from the ceiling or on the ceiling to get the uniformity. When would we use active over passive emitters? From Jonathan. We would use active emitters if we wanted music or paging. I would also use active emitters if we have a very low ceiling, because the lower frequencies will upwardly mask the higher frequencies. So that can give you a slightly more effective sound masking system. And also, if you had a high ceiling where you needed a bit more power to come down, or you wanted a higher level of sound masking. Can this system be used for background music and paging? Yes, it can. Each zone can be assigned music channels or paging channels. There are 2 audio inputs on the 300 and the 600, which we can assign to the necessary channels. Does it work with third-party paging systems? Yes, it does. We use ours with our Vocia paging system, but as long as it's a line input, then the line input will work, and there is a mute button for paging for masking if required, although we try to leave the masking on and page over the masking. Johan has asked the cable length limits when patch panels are in the chain and when usual structural cable runs and patch leads. The total cable, if we're using an existing site with patched cables in, then we have to take the patch cable or the structured cable as part on the length of the run. So that sometimes does limit the number of emitters that you can use on a system in that space. Should power injectors connect to the QT directly, or can I connect between emitters? No, the power injectors ideally should go straight to the controller rather than daisy chaining injectors. Ideally, if you have to daisy chain them, in theory they can do, but we try to keep the zone down to a manageable level. Can we integrate to a fire alarm system? Which means if we get a line out from the fire alarm willies. Well, in theory, yes, you can integrate to a fire alarm system and play sound through the emitters. However, they will form absolutely no part of the fire alarm system whatsoever, because they are not made to any EN or similar standard. Which category cable is recommended? We really tend to say Cat 5, but you can use Cat 3 or above. What happens if you exceed the maximum limits of cabling length and number of emitters? What happens there is we start to affect the impedance of the run, so we don't get the performance that we would wish. With the active emitters, if we go more than the specified amount on the using it for paging and background music, it can start to fail if we have too many. How do cable splitters affect the channels? That's a very good question, Ken. If we start splitting the cables, the channels accordingly, then we do need to bear particular attention to which way the channels are going. I really do try to avoid splitting cables wherever possible at all. How do we control the QT-13600s on the network? Then the QT-100 does not have a LAN connector. That cannot go on the network. The QT-300 and 600 have a control panel which connects through a LAN. It can go onto a customer's network if required, and that has a control panel on there. Can the system be used for background music and masking at the same time? This is from Robert. Yes, it can. We would tend to have the masking on. Go back to the levels that we're talking about. The sound masking is maybe 45. The background music could well be higher, so we can use the type the same at the same time. Question: what are the cable types? Cable types are just a standard category cable, non-screened, so just standard cable. Johannes has asked, does the power injector with its 2 runs also change the order of channel A versus C? No, it doesn't. It's constant, so if it's A in, it's A out. Question here: if one of the emitters fails, does that mean that the zone will not be working? That can mean one of 2 things. Sometimes, if you lose, it depends on the fault that's caused it. Sometimes you may lose everything from the faulty emitter onwards, or you may lose all the A's, for example, all the B's. What I will say is 90% of faults on systems are caused by cabling errors, so it's normally the cable connection. Will the emitter output level adjust according to ambient noise in the room? No, we do not adjust the level of sound masking in the space. We tend to have it ideally as a constant level. Sound masking is needed more when it's quiet, when it's loud generally. So it's far more effective if you have the masking at a constant level so that it's not noticeable. Johan has asked where can we find the information to control system from third-party control products. That should be on the website, Johan. If it's not on the website, please do let me know. I'm 90% sure it is on the website. Do PA speakers affect the sound masking environment from Sunil? No, they don't. Because depending on when we need there will be no conflict between the speakers, and it just needs to consider the reasons why we want both systems there together, but they won't affect it, no. If the ceiling is metal sound masking, yes, yeah, it makes no difference what the ceiling is at all, because we are aiming the sound down into the direct field. The difference that you will find if it's a metal ceiling is that when you come to tune it, you might need to tune it slightly differently because the performance of the metal will be different than a mineral tile. Question from Ken, can we ramp sound masking level by time of day events? Yes, we can. By standard, we have a one ramp up, one ramp down per day per zone. However, you can also do this using third-party products as well. Question, how can we play music and sound masking at the same time through the same driver? This is controlled through the matrix in the controller, where we duplicate the channels that go to the zone. But the active emitter is specifically made to play music. Is it okay to use active emitters for not only masking but also playing background music and office announcements? Yes, that's exactly what we're able to do. The controller has an input source per zone. No, the controllers have 2 input sources in total, which we assign to where we want to go. The minimum, maximum height that recommended for sound masking. If it's anything lower than 2.2 meters, then we really do need to consider maybe putting the emitters closer and also using the active emitter. So much lower than 2.2 meters is not going to be overly effective, and like up to about 6 meters maximum. Does the masking affect web conference microphones? It should not affect web conference microphones if they're a decent microphone. If you have omnidirectional microphones stuck on the ceiling, and it's a high ceiling, then theoretically they will hear the masking. So in those applications, we would use a room controller to mute it. But if we use a proper microphone, then no, it shouldn't do. If the main speaker is not working, will it affect the remaining speaker? That really depends on the fault that we get. So if we have one emitter not working for some reason, that could cause different things, different ways. How does a room control connect to the controller? So the room control is essentially like a volume control. So the cable goes in to the controller and it then goes out to the remaining zones and then tees off to the speakers, the emitters that it wishes to control. So it only controls the speakers in the room. There is a link for that on the website. It's called the RC2 control. Is it possible to increase the input sources? No, you cannot increase the number of input sources on the standard on the controllers. How we would get around that is we would duplicate controllers, and then that gives us more input zones. A question on referring back to the ceiling height that we talked about. If the ceiling is lower than 2.2 meters, it's not recommended for sound masking. If it's lower than 2.2 meters, we need to be cautious about the design and to find out exactly why the customer wants sound masking and see whether there is another way to do it. I think that's probably about it. But if anybody does have anything further, my contact details are here. Please do email me if there are any questions. Please email the distributors in the country or any Biamp team members, and we will share the presentation. There will be an email coming through with the presentation to start with, and I will also share the link for the design guide as well that will come through with the email as well. So I would like to thank you all for joining, and thank you.